Hi everyone, this is just a quick video on ions and isotopes. If you missed class, please watch this video and catch up. Please let me know if you have any questions. So the first thing that I wanted to mention was that on our previous homework, which was the element inventory, the last two rows were both carbon. As it says on the screen, this was not a mistake. This was actually a lead-in to what we're going to talk about today, which are isotopes. So if you look at the two lines that I copy pasted from that homework assignment, you'll notice that the two carbon atoms have the same number of protons, they have the same atomic number, but they have different mass numbers. And that's because they have different numbers of neutrons. So today we're going to learn that isotopes are two versions of the same element, but they have different numbers of neutrons and therefore they have different mass numbers. So let's take a look at our next slide. As you can see, it says an isotope is one of two or more forms of the same element that contain equal numbers of protons, because remember, protons are what determine what atom you are talking about. So if they have the same number of protons, they are the same atom, but they have different numbers of neutrons. So if you look at the three examples that I have on the bottom here, the first one that you're going to notice has a mass number of 1. So there's 1 proton, but there are no neutrons. This over here is an electron. The second isotope has 1 proton and 1 neutron. So it would have a mass number of 2. The third example, all the way on the right side, has a mass number of 3. It has 1 proton and 2 neutrons. But it's really the protons that are important. The protons are 1 in each of these examples. Therefore, it's the same atom in all three examples, just different isotopes. Okay, let's take a look at the next slide. So the question is, are the two of them isotopes? So for example number 1, it says that we have 6 protons, 6 neutrons, and 6 electrons. So the question is, are the two of them isotopes? And the answer to the first one is yes, they are both isotopes because they have the same number of protons, that's these numbers, but different numbers of neutrons. So down here, I would write yes. And for the atom, I would write carbon. Carbon is the atom that has 6 protons. Let's take a look at our next slide. So in this question, again, we're answering, are the two of them isotopes? So the first thing that we do is look at protons. So they are both 2 protons, so they're both the same element, and they have different numbers of neutrons. So yes, they are isotopes, so I would write a yes down here. And then for what atom it is, they are isotopes of the atom helium because they have 2 protons. Third example, so I have 12 protons here, and I have 11 protons here. So are they isotopes? The answer that I would write down here is no. These are 2 different atoms. So this with 12 protons is the atom for magnesium, and this with 11 protons is the atom for sodium. So are they isotopes? The answer to that is no. And then we don't have to fill this part in because they are 2 different atoms. One is sodium, one is magnesium. Finally, example 4. We have 16 protons. We have 18 neutrons and 16 neutrons. So the question is, are they isotopes? The answer is yes. They are both isotopes of the atom sulfur. They have the same number of protons, but different numbers of neutrons. Okay, moving on to our second piece here. So this little lesson is called Isotopes and Ions, or Ions and Isotopes. So we talked about the isotope part. Today we're going to focus on the ion part. So it says that an ion is an atom or a molecule in which the total number of electrons are not equal to the total number of protons, giving the atom or molecule a net positive or a net negative electrical charge. So if you look at the bottom here, the first atom that we have is sodium. So sodium has 11 protons, and if you were to count up all of these little circles over here, these are the electrons, including this one, you would find out that this has 11 electrons. So 11 protons, 11 electrons, they cancel each other out, so it has a charge of 0. Same thing over here with chlorine. Chlorine has 17 protons, 17 electrons. They cancel each other out, so its charge would be 0. When sodium gives an electron, that's what this arrow is showing, it's going to give one of its electrons to chlorine. So this electron here moves over to where this spot is over here. So now afterward, this atom has 11 protons, but now it only has 10 electrons. So it has more protons than it has electrons. More protons than electrons by 1. So it ends up with a +1 charge. Over here, we have chlorine. Chlorine has 17 protons, but because it gained an electron, it now has 18 electrons. So it has more electrons than it has protons. So it has a negative charge, a -1 charge, because it has one more electron than it has protons. So we're going to go through a few examples here. Is the ion positive or negative? And then we're going to try and figure out how positive or negative it is. So in this example, I have 29 protons, that's positive. I have 27 electrons. So we're looking at the top number here, protons, and the bottom number here, electrons. The number of neutrons does not affect the charge that an ion would have. So because these two numbers, 29 and 27, are not equal to each other, this is going to be a charge. And because we have more of the protons, that part's up here, it's going to be a positive charge, and we're going to call it +2. +2 because it has 2 more protons than it has electrons. So 2 more protons than it has electrons. Okay, next part. We are going to move on to the next page. So let's hit that. So in our next example, we have sulfur. So this time we have 16 protons. We have 18 electrons. So because we have more electrons, the overall charge is going to be negative. So this ion is going to be negative. And then because we have 2 more, 18 compared to 16, because we have 2 more electrons, we're going to call this a -2 charge. So this ion is going to have a charge of -2 because we have 2 more electrons than we have protons. Third example, barium. So with barium, we have 56 protons, we have 54 electrons. So with 56 protons, that means we have more protons than we have electrons. So this is going to have a positive charge. And then it's going to be +2 because we have 2 more protons, 56, compared to 54 electrons. So the ion down here would be +2. Okay, the next part. We are going to look at iron. Iron is going to be our last example. We have 26 protons here. We have 23 electrons here. So because we have more protons than we have electrons by 3, we're going to end up with a positive charge. And that charge is in fact going to be +3 because we have 3 more protons than we have electrons. All right, so let's take a look at the assignment that I'm asking you to do. Okay, as you can see, I've now switched to the ions and isotopes assignment. So you're going to need your periodic table in order to figure this out. So I'm going to try and go through this. I'll go through about half of them with you, and then I would like you to try some of these on your own. So the first example, we have magnesium. So I would look up magnesium on my periodic table. And then in the spot where it says symbol, we're going to type in the symbol for magnesium, which is Mg. In the atomic number spot, the atomic number for magnesium is 12. So we're going to type in the number 12 here. And remember that, see these stars on top? Whatever number goes in the atomic number column, that's what also goes into the number of protons column. So this answer will also be 12. So the next part is for you to compare, just like we were doing in the examples, the number of protons, which is 12 in this case, and the number of electrons, which is 10. So because I have 2 more protons than I have electrons, I'm going to wind up with a positive charge. And in this case, it's going to be a positive 2 charge. The last part is to go and figure out how many neutrons I have. So these 3 boxes that are up here in green, the protons and neutrons should add together to give you the mass number. So if the mass is 26 and these 2 numbers add together to give you 26, that means the number of neutrons has to be 14. Okay, the next one's a little tricky. So in the next example, what you actually have to do is figure out, based on the charge, there's a -2 charge here, you have to figure out what your number of protons is going to be. So in order to do this, you're going to need to look at your periodic table. So if you look at your periodic table, you're going to find something around the 50s. A -2 charge means you have more electrons by 2. So if I have this many, 54 electrons, and I have more electrons by 2, that means my number of protons has to be 52. So I can go to my periodic table, find element number 52. Element number 52 is tellurium. So I could type in tellurium in the name spot, and then in the symbol spot, I could type in Te. The last part is to add these 2 pieces together, the number of protons and the number of neutrons, to get my mass number. In this case, that mass number is going to be 125. Okay, for the next example, they give you the element cadmium. So you would find this symbol on your periodic table. It is element number 48. So I can take 48 and put it in both the atomic number and the number of protons spot. Now I'm going to compare my number of protons, which is 48, to my number of electrons, which is 46. Because I have more of the positive protons, I know that my charge is going to be positive by 2, because it's 48 compared to 46. The last part of this is to add together my protons and electrons. So when I do that, I wind up with 113. My next example, I have atomic number 51. So atomic number 51, I'm going to find that on my periodic table. So that's antimony. The symbol for antimony is Sb. This atomic number, which is 51, I'm going to fill in over here as my number of protons. Now, I'm going to look at the charge. The charge is -3. That means I have more electrons, because electrons are negative. I have more electrons by 3. So if I have 51 positives, I must have 54 negatives. And then finally, for the last part, I have 120 as my mass number. I'm going to subtract out 51 protons. So that's going to leave me with 69 neutrons. 69 plus 51 adds up to give you 120. Okay, my next example. My next example is tungsten. So if you find tungsten on your periodic table, you'll see that it has the symbol W. It is atomic number 74. So for my number of protons, I can put 74. Now notice the charge. So I want to get ready to fill in my number of electrons. I have a positive charge by 6. So that means I have 6 more positives than I have negatives. So if I have 74 positives, I have to subtract 6 to get 68 negatives. And then finally, for the last part, what number plus 74 will add up to give me 184? That number is 110. Okay, if I take a look at my next example, in my next example, I have 35 protons, 36 electrons. So I have more electrons than I have protons. So I have a -1 charge here. If I look up the number of protons, I'm going to put that number over here as well, 35. That means I'm talking about the element bromine. So I could fill in bromine over here, type in the symbol for bromine, and then the last piece is to add together these two numbers, 35 and 51. So if I add those two together, I'll get bromine with an atomic, with a mass number rather, of 86. Okay, at this point, we have done half of the assignment. I am asking you to finish the other half of the assignment on your own. Please remember that when you finish the assignment, I would like you to submit it so that I can grade it. And if you have any questions, please reach out to me through an email or through Schoology. Thanks very much, everyone. I hope everyone has a great day.